All right, welcome to lesson 2.03. This is going to be a lesson that hopefully brings together a lot of the conceptual understanding that we have about a function and its derivative and allows us to deepen it by thinking about the relationship between a function and its derivative graphically. We actually talked briefly about this the other day. All right, so here we go with the discovery problem. Before copying out the whole problem, I want you to first copy out part A and spend 30 seconds, a minute, going back, reminding yourself of the relationship and just writing it out in as short and succinct a sentence as you can. Then move on to B and C. And once you've completed B and C, press play, and I'll show you part D. Okay, so now we're going to take the information that you've gotten from answering parts B and C and apply it to a bigger idea. All right, here we go. So give part D a try. You can do this perfectly well just by incorporating the understanding you have of the relationship between the function and its derivative, and then also with the information that you've gotten from parts B and C. All right. I really hope that you found this actually to be easier maybe than you might have thought it would be at the very beginning, because it truly is in fact very, very simple. Let's think about what we remember from A, B, and C. So the relationship between a function and its derivative is that the derivative gives you the slope of the function f at any value x. Or in this case, d prime of t will give you the slope of d of t at any point t. So consider now what we're actually figuring out when we look at the slope of the function d at this point a. The value of the slope is exactly the value that we're getting when we evaluate d prime at that particular t value. So when we look at the slope, we say, well, you know what? The slope is certainly going to be positive here. That means that d prime of this value, and let's just call this value, this is 1, right? D prime of 1 is certainly going to be positive. So if I'm looking at my graph of d prime, I better have a positive value for d prime at 1. Okay, what do you think the slope of d is at the point C? Well, let's look at C, and this appears to be the t value 2 seconds in. Well, what do you notice about this slope? Imagine that you were trying to compute the slope of C. Well, let's say you took a point just to the left and a point just to the right. Those points are pretty much at the same spot, right, on the y-axis. So your change in y is going to be pretty much 0, meaning that, just as you might assume, right, this is pretty flat. There's almost no slope here. And we've seen this before when we've run into tangent lines that are horizontal. And so we'd say the slope at C, it looks like it's 0. And what does that mean about d prime of 2? Well, d prime gives you the slope of the function d. So d prime of 2 better be 0. And this information is going to make sketching a graph of d prime very, very easy. So we know that d prime of 2 is going to be a root of the function. It's going to intersect the t-axis there. We know that up until that point, we have a slope that is positive. And what you might guess is, look, this slope is positive. It's steeper here, and it gets shallower and shallower as we get closer to that slope of 0. So the value d prime, it's going to be a bigger slope, smaller slope, smaller slope, smaller slope, smaller slope, smaller slope, until your slope is 0. Once the slope hits 0, then what happens? Well, now the d of t function, the distance, starts to decrease, and so the slope becomes negative. So our slope is going to be negative down here, up until the point where, again, my function is d of t is perfectly flat, and so my slope is 0 again at 5. And so I'll have another root there. Now past 5, the function d of t again will have a positive slope, and so my function will be positive. And so I can actually think about making just a couple of markings here to help me remember, right? So the function is going to be positive between 0 and 2, right? Then I've got that it hits 0. Then my function is going to be, d prime of t is going to be negative. And then past 5, after it hits 0 again, it's going to be positive again. And so this will help me really envision what my function is going to look like. D prime is going to be positive over here, negative over here. It's going to have to come back and hit 0 and be positive here. So the last thing that we want to think about is how does it go from being positive to negative? In other words, look at the slope. Well, the slope is pretty steep here. But in order for it to get to 0, since it's a continuous function, it's going to have to gradually, the slope's going to have to shallow out. So it's pretty steep, and as I get closer to where it's 0, it's going to get shallower. Meaning the value of my function d prime is going to have a bigger value up here. The slope is bigger here. But as I get closer to the value 2, where the slope is 0, the function d prime is going to decrease in its slope until it gets to 0. Moving past c, we notice, right, it's going to have to be negative, but it's going to be very slightly negative, right? It's going to be very small and negative, and then at some point it's going to get pretty steep. So the steepest value of d is right in between 2 and 5. And so right in between 2 and 5, we should have the most negative value of d prime. And from that point, it then begins to shallow out again. In other words, the slope gets smaller and smaller and smaller until, again, it hits 0 and then increases. And there it is. So if you're thinking about kind of creating a protocol for yourself, you might imagine that what I want to do is figure out where is d prime going to be 0, right? Where are the roots? And then what is the value of the slope going to be on either side of the roots, right? Is the slope going to be positive? Is the slope going to be negative? Is the slope going to be positive? And then once you've decided positive or negative, you can think about, okay, well, the slope should probably be decreasing. Let me just check to make sure. Yes, right? Slope is decreasing, getting shallower and shallower until I hit 2, so on and so forth. And it makes it very, very easy to sketch a graph of the derivative. All right, so if I'm going to graph the function f prime and I just have the function f, there are some very easy steps that we want to take that will allow us to sketch a really accurate graph of the derivative. So the first thing that we want to do is, and you'll notice this will probably sound kind of familiar to something we've done before, we want to locate where the derivative will be 0. Right? So if you're thinking about derivative always as the slope of your function f, where is the slope of your function f going to be 0? So you can look at the graph and say, okay, here's where it's going to be perfectly flat. These are going to be places, and you're going to want to add this in. These are where you're changing from a positive slope to a negative slope, right? Where you are rising, but all of a sudden then you're falling. In between there, you're going to get a slope of 0. We're actually going to talk about that more a little later on. So you can locate where the derivative will be 0, and then you want to determine the sign, either positive or negative, of the derivative for each of those intervals in between your zeros. Now, what I'm really doing here is creating a sign chart. I'll show you what that looks like. So, for example, let's say you discover that the x values where your derivative will be 0 are going to be at 2 and 4. Okay, so that's where you're going to intersect the x-axis, and then in between there, maybe you know that we're going to have positive, negative, positive. So then when you go to graph this function, you know, look, it's going to intersect, the derivative will be 0 at 2, it will be 0 at 4, it's positive, and it will look something like that, right? So this is a sign chart, and you can begin making these for these problems. We're going to make lots of sign charts. They're very, very helpful, and they help you organize your work. And once, of course, that you've graphed your derivative, if this were f prime, you'd want to go back and you'd want to check that it makes sense. Just look it over once more. Right, here are some for you to try. So your goal is to match each graph with its corresponding graph of its derivative. So here you have a bunch of functions, and you want to match them up with the graph over here that represents its derivative. All right, so make sure you get all of these, have a reasoning, show your work, so that way you can present. And then what I'm also going to give you are a couple of kind of just basic review problems to make sure that you're staying fresh on finding derivatives and your work with limits. So that'll come up in about 5 seconds. Here are a few more. They're all review questions. The last one might take you a minute or two, but for the most part, you should breeze through these quickly. Make sure you show all your work and you're using the definition of the derivative or your protocol with limits up here for 1 through 3.